Hi everybody, and welcome to this unit on layering. So let's start off by taking a look at what layering actually is. Layering is a method of rooting stem cuttings where the stem remains attached to the mother plant while adventitious roots are initiated. Once a large enough root system has developed, you cut off the rooted stem from the mother plant and pot it up. On the right you can see a diagram of a very basic layering technique where a long flexible stem near the crown of the mother plant has been bent down so that part of it is in contact with the ground. Roots will develop here at the bend, and then the distal end of the stem with the roots attached will be removed and potted up. Self-layer, and most of you have probably noticed plants that do this, especially low-growing ground cover shrubs with a prostrate growth habit, which have a lot of their stems in contact with the ground. Edible plants that naturally layer include strawberries, which produce stolons or runners, with new plantlets at each node that develop roots. Wild blackberries also self-layer, and their stem tips will root as the long stems arch over and touch the ground. Some herbaceous plants, such as penstemon, have upright stems initially, which become top-heavy when they bloom, causing them to bend over. The stems then produce roots where they're in contact with the ground. Some upright succulents, such as some of the aeoniums, have a similar tendency, and many of the trailing succulents, such as chalksticks, Kleinia mandriliscae, and stone crops produce adventitious roots along their stems. Many of our California native shrubs, such as ceanothus, salvia, and manzanita, will also self-layer on the underside of any stems that are in contact with the ground. And there's a really nice example of a manzanita doing this in the upper garden at Cabrillo. Layering is a really ancient propagation technique, and it continued to be commonly used in commercial horticulture up until the mid-20th century. Many of the woody ornamental plants that were popularized in the US and Western Europe from the late 1800s through the 1950s, such as magnolia, catinus, syringa, hydrangea, daphne, and rhododendron, all used to be propagated by layering until the mid-1950s. What changed the widespread use of layering was the development of synthetic auxin-based rooting compounds and improvements in greenhouse technology, which enabled propagators to manage the propagation environment much more easily. Increasingly, tissue culture methods are also replacing the use of layering techniques, especially in the production of fruit tree rootstocks. You may be wondering then why you need to learn about layering techniques if they're no longer widely used. As you'll see later in the module, though, there are still some layering techniques that are widely used in the nursery industry. Also, tissue culture and stem cuttings don't always work for every plant, so having some knowledge of these older traditional propagation techniques that do work can be really useful. Tissue culture protocols are expensive to establish, so it's often just not economically feasible to do all the research and development for tissue culture if plants aren't sold in large enough volumes to recoup these upfront expenses. Layering techniques can also be useful if you're working for a smaller or specialist nursery that wants to differentiate itself from larger nurseries by offering rare or unusual plants that the larger nurseries have no interest in propagating because they just don't sell in large enough quantities. Layering techniques are also useful for small-scale propagation in conservation and botanical gardens. So let's look now at the main layering techniques. The most basic layering technique is simple layering, and you saw a diagram of this at the beginning of the lecture. Here, a low-growing flexible stem is bent down to the ground and held in place with something like a landscape staple. Sometimes the bent stem will be buried in a shallow trench or hole. Some people like to make a cut in the stem at the point where it touches the ground, and also apply rooting compound, as this can encourage the stem to root faster. Once rooted, the layer can be cut off and transplanted. Simple layering doesn't necessarily need to be done on plants that are in the ground. It can also be done with mother plants that are in containers, and the stems are pegged down into other adjacent containers. Doing simple layering like this can help reduce problems with soil-borne pathogens. Compound and serpentine layering are both variations of simple layering that involve much longer stems and multiple nodes. With compound layering, the whole stem is partially or completely buried. And with serpentine layering, a long flexible stem is woven in and out of the soil and pegged down at the points that are below ground. Compound and serpentine layering are useful techniques for shrubs with long, flexible stems, or for vines such as our California native vine, Dutchman's pipe, Aristolochia californica, which is the larval host plant for the pipevine swallowtail butterfly. In the photo here, you can see a demonstration of compound layering of magnolia at the Tree Nursery Museum in Boskoop in the Netherlands. Boskoop is the historical centre of Holland's nursery industry, and it continues to have a lot of nurseries today, but most of them are small specialty nurseries and don't have the greenhouse technology and aren't the same size as many of the other larger nurseries that you see elsewhere in Holland. But Boskoop is definitely worth a visit if you ever find yourself in the Netherlands. One of the layering techniques that's still widely used today is mounding or stooling. This technique is widely used for the production of apple tree rootstocks in both the US and Europe. With mounding, the mother plant is established in the ground or in a large container, and the stems are cut back to around 1 to 2 inches above the soil or substrate. As the stems grow, a very freely draining substrate such as sawdust or coir is mounded up around their base. This procedure is repeated at least once more as the stems grow. In time, the stems produce adventitious roots and are then removed from the mother plant and can be potted up. In the case of fruit tree rootstocks, the rooted layers are washed, graded, and put into cold storage, then shipped to customers throughout the US or Europe during the dormant season. Mounding techniques can be really useful in the development of new cultivars of woody plants that are hard to root from cuttings, and where the development of tissue culture protocols is cost prohibitive. For example, at Utah State University, Dr. Larry Rupp and some of his students have been making selections of one of their native oaks, Quercus gambellii, Gambel's oak, that have attractive characteristics for the landscape market in Utah. Growing the oaks from seed won't work for them because it won't reproduce the desirable characteristics, and oaks are not easy to root from cuttings. So Dr. Rupp has been using mounding techniques to propagate his oak selections vegetatively. Finally, there's air layering, which is also called pot layering, marcotage, Chinese layering, or guti. Air layering is still used in some countries where labor is cheap, and in the US it's regained some commercial popularity in the last 20 years or so in nurseries in the southwestern states for the propagation of a small number of slow-growing ornamental trees that are native to the Sonoran Desert and are difficult to root from stem cuttings. These trees include several Palo Verde species, including the Desert Museum Palo Verde, which you can see in the photo here. This attractive tree is a three-way cross between Parkinsonia microphylla, Florida, and Aculeata. In Spanish, Palo Verde means green stick and refers to the green stems of these desert trees, which contain chlorophyll for photosynthesis. Palo Verdes are really popular ornamental trees in Arizona. The process of air layering usually involves first partially or fully girdling a stem. Girdling is a process where you remove a strip of bark all the way around a stem, and you make your cut deep enough so that the phloem is also cut in that particular section of stem. You don't cut so deeply, though, that the transport of water and nutrients in the xylem is interrupted. So how deeply do we need to cut? There are two diagrams on the right here. The upper diagram shows the cross-section through a woody dicot stem, and the lower diagram shows a cross-section through a herbaceous dicot stem. And a one-year-old woody dicot would look very similar to this herbaceous plant at the bottom here. So the outer layer, the one that's labeled as the epidermis here, is what we normally think of as the bark. But in actual fact, the bark technically includes all of this area from the outer corky epidermis all the way through to the vascular cambium, which is a ring that'll develop here between the phloem and the xylem. These acorn or egg-shaped structures here are the vascular bundles, and the phloem are on the outside here, and then on the inside you've got the xylem. If you look carefully, you can actually count the number of cells, more or less, between the corky epidermis and the phloem. And you can see that there are only about 3 or 4 cells. Each of these cells is probably around 0.1 millimeters in diameter, which means that the phloem is only about 0.3 or 0.4 millimeters below the epidermis. This illustrates the point that you really don't need to make your girdling cut very deep. If you do, you'll also disrupt the flow of water and nutrients in the xylem, and the section of stem above the girdle will die. The process of girdling blocks the transport of photosynthates in the phloem, and this was first reported in 1928 by the plant scientists Mason and Maskell when they were working on cotton. The process of girdling can be done deliberately by humans, as in air layering. The process is also used sometimes in conservation work to kill invasive trees, and here the whole trunk is girdled, not just an individual stem. And if they're trying to kill the tree, then sometimes they'll make the girdle much deeper so that it also cuts into the xylem. Girdling can also be done by animals such as voles or mice nibbling away at the base of the trunk of a tree or shrub. It can also be done by careless gardeners weed whacking too close to the base of a tree. In commercial orchards, tree guards are sometimes used on newly planted trees to protect the trunks from being girdled or damaged by rodents. So let's go back to air layering as a propagation technique. After girdling a suitable stem, you apply a rooting compound to the cut area, and the strength will depend on the species. 5,000 parts per million of IBA has been shown to work well for the Desert Museum Palo Verde tree that I mentioned earlier. You then wrap the cut section of stem with a thick layer of moistened substrate, such as peat or coir, or you can use large stabilized media plugs. You then tightly wrap the substrate with plastic wrap to hold it in place, and you can then cover that with a layer of aluminum foil to prevent the layer from becoming too hot. The end result in a commercial nursery is a mother tree that looks like it's got a load of small burritos in the canopy. Once the layer has rooted, the stem can be removed from the mother plant and potted up. So let's finish this lecture with a quick look at the advantages and disadvantages of layering techniques. Firstly, layering is low-tech and usually low-cost because it doesn't need any investment in specialized equipment or facilities, although it is labor-intensive, so that can add to the cost. Secondly, the rooted cuttings from layering are usually relatively large compared to stem cuttings that would be rooted in a greenhouse, so you may get a better survival rate. And the rooted layers may reach a marketable size in less time than with cuttings, especially with some of the particularly slow-growing desert species, such as Chilean mesquite and the Palo Verdes. In commercial nurseries in Arizona, it's not unusual for the rooted layers to be about 3 feet long and to be potted up straight into a No. 5 container. In contrast, a rooted stem cutting would only be a maximum of about 6 inches tall. Thirdly, layers need less care during rooting than stem cuttings or seed because you don't need to check them every day to make sure, for example, that the mist system's working. And fourthly, layering has the advantage of bypassing the juvenile period in fruiting species, so the plants you get from layering are mature and able to produce fruit in the first growing season. Make a note, though, that this isn't important or relevant for the production of fruit tree rootstocks, because these aren't going to form part of the grafted tree variety that bears fruit. Layering, of course, also has its disadvantages. It's labor intensive, so therefore there's a relatively high labor cost, and you need to be able to pass on these costs to your customers. This isn't usually important where layering is being used in a botanical garden or for conservation, though, because profitability isn't the main objective of the organization. Although, of course, making sure that there aren't any cost overruns is also important. Like grafting, some layering techniques, especially air layering, require skill with a knife and good manual dexterity. These are skills that not all workers have, including me. So you need to make sure your workers are able to do the work and that they're taught well on how to make the cuts and why they shouldn't make them too deeply. It's very easy for air layers to fail because the girdling isn't done deeply enough, or is done so deeply that the stem dies. The amount of propagation material available for layering is usually relatively low compared to the number of, say, stem cuttings you could obtain if this were a viable method. Again, this lack of propagules needs to be factored into the price of any marketable plants. Large-scale layering takes up a lot of land, and as we all know, land is extremely expensive in California. So again, this means that layering in large numbers may not be a cost-effective use of the land here, and increasingly throughout the Pacific Northwest as well. Layering can be slow, although if the alternative is not being able to propagate the plant at all, then slow probably isn't a disadvantage. And finally, for layering that's done in mineral soil, soil-borne pathogens can be challenging. In Oregon, where many acres of land are used to propagate apple and pear rootstocks from stool beds, the fields have to be maintained free of nematodes and the virus pathogens that they're vectors of. Growers of fruit tree rootstocks, which are often being shipped to other growers across the country, have to have their fields inspected on an annual basis in order to produce rootstocks that are certified clean. Strict adherence to effective pest management protocols are therefore vital, as discovery of pathogens could be financially devastating when you're growing rootstocks on such a large field scale. Let's finish this lecture with a quick summary. Layering techniques are old and have mostly been replaced by advances in plant science, greenhouse technology, and tissue culture. But layering still has a place in modern propagation, especially in smaller nurseries and specialty nurseries, and in conservation. So don't forget about these layering techniques, and remember that they can still form a really important tool in your toolbox of propagation techniques. Thanks for listening. Head back to Canvas now to continue with this module.